Companies spend millions building massive digital perimeters, trusting these glowing firewalls to deflect high-speed attacks from the outside world. But that armor fails when the attacker is already sitting 3 desks down, quietly intercepting your most sensitive data. To understand this breach, we have to look at the local office network, specifically the Layer 2 switch connecting the employees. This local hardware layer operates on a dangerous assumption. It is completely blind to intent. The system assumes that if a device is physically plugged into a wall port, it has a legitimate reason to be there. A bad actor exploits this by plugging in a malicious device, specifically configured to impersonate the network's own infrastructure. Multi-million-dollar perimeter defenses are neutralized the moment an internal network blindly trusts a physical connection. This diagram shows a standard local network. The legitimate DHCP server, the machine that assigns IP addresses, is located far upstream from the local clients. When a laptop boots up, it broadcasts a request into the void, asking the network to assign it an IP address. A rogue machine connected to a dark corner of this same local network hears that request. Because this attacker is physically closer to the laptop than the real server, it wins the race, firing back a response before the legitimate server can react. The attacker hands the victim a counterfeit IP address assignment, effectively mislabeling the machine's place on the network. Operating on blind trust, the laptop accepts the offer, handing control of its identity to the attacker. The attacker infiltrates the system by exploiting the protocol's lack of source verification and winning a simple foot race. With the fake IP assigned, the attacker initiates art poisoning to physically hijack the data stream. The rogue device sends malicious data packets that forcefully rewrites the victim's local address book. This poisoned directory misdirects the victim, telling the laptop that the attacker's machine is the actual gateway to the internet. This creates a man-in-the-middle scenario. Outgoing data now flows directly through the attacker. The attacker can now read, modify, or destroy any data before quietly forwarding it to the real internet. By manipulating the internal road signs, the rogue server dictates the victim's reality without ever triggering the external firewall. To stop these hijacks, network engineers change how the central switch handles traffic. They implement DHCP snooping, a security protocol that forces the switch to stop blindly trusting every device. The uplink to the true internet is designated as the only trusted port. All local client connections are downgraded to untrusted ports. Now, when the rogue server attempts to send a fake DHCP offer from an untrusted port, the switch recognizes the violation and instantly destroys the packet. By revoking default physical trust, the network engineer strips local rogue devices of their ability to issue identities. Silencing the rogue server is the first step, but the network must also prevent further attempts at address spoofing. The network uses legitimate traffic to automatically build a verified master guest list of IP and MAC addresses. This master list powers dynamic ARP inspection, or DAI, which automatically validates every single internal request against those verified entries. If an attacker tries to send a poisoned ARP packet, DAI detects the mismatched ID and vaporizes the data before it can cause harm. Cybersecurity isn't just a wall at the perimeter, it is the real-time verification of every single handshake happening inside the house.